Hi everyone. So let's talk on the conditions for estimability. In this lecture, we will see some necessary and sufficient conditions for the estimability of linear parametric function. Already in previous lecture, we have seen that we have three methods to prove that the estimability of linear parametric function. Uh, Let's discuss them one by one. So, see, what is the topic? The topic is necessary and sufficient condition for estimability of linear parametric function. So, this is our today's topic. We need to prove the three methods. As you know, y curl is equal to x beta curl plus epsilon. ठीक है और epsilon will follow normal 0 comma sigma square identity. Under general linear model, we have the model that's y curl x beta curl comma sigma square identity. Whenever you find the mean and variance of this GLM, you will get x beta curl sigma square identity variance for mean x beta curl. Clear? So the last uh, in previous lecture, we have seen the three methods. The method one was a linear parametric function C curl transpose beta curl is said to be estimable if and only if there exists a vector A curl such that A curl transpose X curl is equal to C curl transpose. Clear? Let's find the necessary condition for this. The first condition is a necessary condition. That is nothing but we are given with C curl transpose beta curl is estimable. We are given with this is estimable. On the basis of this information that is given, we need to prove A curl transpose X curl is equal to C curl transpose. Clear? Now the proof of this is if C curl transpose beta curl is estimable, then there exists a vector A curl such that expected value of A curl transpose X curl is equal to C curl transpose beta curl. We need to prove this. See, this term will come out as a constant, that is A curl transpose then expected value of, this is A curl y, this is A curl y. This is A curl transpose y curl. So expected value of y curl. As x is my non-stochastic, that's non-random, but y is my random. So the expected value will operate only on random variables. So this is expected value of this is equal to, we need to prove left hand side is equal to right hand side. So this is A curl transpose expected value of Y curl. So this is A curl transpose. What's expected value of Y curl? Y is my X beta curl. That is simply X beta curl is equal to C curl transpose beta curl. So this beta curl will cancel out. So A curl transpose X is equal to C curl transpose. Where uh, whatever will be the B, this is equal to this. This is equal to this. You can write this as in the form of vector as well. This X curl will be vector, and you can write this in the form of vector as well, but no need to write. This is understood that A curl transpose X is equal to C curl transpose. Now this sufficient part of this, the sufficient part, we are given with that A curl transpose X is equal to C curl transpose. Then to prove that C curl transpose beta curl is estimable. Now proof. Consider C curl transpose beta curl is equal to A curl transpose X beta curl. Let's consider this. So here this will be nothing but A curl transpose expected value of Y as expected value of Y curl, as we have already we have already proved that expected value of Y curl is X beta curl from the necessary part. So this is nothing but expected value of A curl transpose Y curl. So as you know from the theorem, from the definition, that if expected value of A curl transpose Y curl is equal to C curl transpose beta curl, then C curl transpose beta curl is estimable. This proves the first method of the condition that a linear parametric function is to be estimable. Now second method, that is nothing but a linear parametric function C curl transpose beta curl is said to be estimable if and only if there exists a vector R curl such that R curl transpose X is equal to C curl transpose. C curl transpose. Then the necessary part of this a method or necessary condition, that's we are given with C curl transpose beta curl is estimable. C curl transpose beta curl is estimable. So we need to prove R curl transpose X is equal to C curl transpose. Proof. Proof is simple. Since we know that C curl transpose beta curl is estimable, then there exists a vector A curl such that A curl transpose is equal to C curl from first condition, and let's write this here. Since C curl transpose beta curl is estimable, then there exists a vector R curl transpose, or simply from first condition we know that C curl transpose is C curl transpose beta curl is estimable. Then there exists a vector A curl such that A curl transpose X is equal to C curl transpose from condition first, yeah, from method first. Or we can write this as X transpose A curl is equal to C. Put it equation number 1. Thus there exists a solution to the system of P equations given in first. So this system has P equations. This system has P equations, right? Whenever we write this in matrix form, you will get a system of equations from first. Then a necessary and sufficient condition for a system of equations, and those equations are linear. Those equations are linear, and the system of equations to have a solution is simply a rank of X transpose is equal to rank of X transpose augmented C curl. This is a non-homogeneous system. If if the set of equations, a system of P equations, has the rank and also rank of X transpose augmented C curl. C curl is also a vector, that's a column vector, right? So this should be equal to rank of X, and that should be equal to rank of X transpose X. Let's write this equation 2. See, whenever we have the system of linear equations to be consistent as well, then this condition will hold in that case. So we are trying to see the consistent solution of the P equations, then this condition must hold. Now, X transpose X augmented C curl is equal to X transpose augmented C into the matrix, this matrix. This is the matrix X. This is the matrix with element 0. This is the matrix with element 0. This is the matrix identity matrix, right? So what's identity matrix? That is this is my identity matrix of order n cross n. Diagonal elements are only unit. The diagonal elements has unit value, that's 1 1 1 1 1, and the non-diagonal elements or off diagonal elements are 0. So rank of X transpose X augmented C curl is less or equal to rank of X transpose C curl. You can also write this as this: rank of X transpose X augmented C curl is less or equal to rank of X transpose augmented C curl. So therefore rank of product of two matrices cannot exceed the rank of any one of them. Also, we can write this as rank of X augmented C curl. See, rank of product of two matrices. The matrices will be, if one matrix is X, the other matrix will be the transpose of that matrix. That's X transpose X. So we can write this as X transpose X augmented C curl is less or equal to rank of X transpose X. This is equation number 3. Now, by definition of rank, if we say rank of X transpose X augmented, say if this is greater or equal to X transpose X, let's suppose this is equation number 4. Then from 3 and 4, can we write rank of X transpose X augmented C curl is equal to rank of X transpose X. This means that there exists a solution to a system of linear equations such that X transpose X R curl will be equal to C curl and R curl transpose X transpose X is equal to C curl transpose. This was the necessary condition or necessary part. Now sufficient part. Now sufficient part. We are given with R curl transpose X is equal to C curl transpose. To prove C curl transpose beta curl is estimable. See, in necessary part we proved that this is equal to this, and in sufficient part we take the reverse of the necessary part. That is simply we are given with this. In necessary part we proved this, and in sufficient part that's given, and we need to prove that C curl transpose beta curl is estimable, and in necessary part this is given, right? So consider the proof. So consider C curl transpose beta curl is equal to R curl transpose X beta curl. Can I write this as A curl transpose X beta curl, as because A curl transpose is equal to R curl transpose X transpose. So what is this? This is A curl transpose. What is this? This is expected value of Y curl. So simply this is equal to expected value of A curl transpose Y curl. So this condition satisfies that expected value of A curl transpose Y curl is equal to C curl transpose beta curl. So therefore C curl transpose beta curl is estimable. Right? Now come to the method third, that is nothing but a linear parametric function. C curl transpose beta curl is said to be estimable if and only if there exists a symmetric generalized inverse G of X transpose X such that C curl transpose G X transpose X is equal to C curl transpose. Now necessary part of this will be we are given with C curl transpose beta curl is estimable, and we need to prove that C transpose is equal to C curl transpose is equal to C curl transpose G X transpose X, where G is generalized inverse of X transpose X. You can indicate transpose as the letter T or simple comma. Now proof. Since C curl transpose beta curl is estimable, then there exists a vector R curl such that R curl transpose X is equal to C curl transpose from condition second on method second. Now multiply with G on the left hand side. Simply we can do one thing: C curl transpose G X transpose X, that is R curl transpose X G X transpose X. In the place of C, I substitute the value of this. Simply. So this will be nothing but R curl transpose X transpose X. This is equal to C curl transpose. Hence proved. Now sufficient part. As we know that we are given with C curl transpose is equal to C curl transpose G X transpose X, where G is a generalized inverse. Now to prove C curl transpose beta curl is estimable. Now proof. As we know, C curl transpose beta curl is equal to C curl transpose G X transpose X beta curl. Now can I write this as C curl transpose G X transpose, but I can write in place of this, that is expected value of Y curl. So this is, let's suppose this is A curl transpose expected value of Y curl, where because we can write A curl transpose is equal to C curl transpose G X transpose. So this is nothing but expected value of A curl transpose Y curl. So therefore C curl transpose beta curl is estimable.